Yes. Guys, listen please. And the last part in chapter 3, momentum. Momentum يكون sections 3.7 and 3.8. Okay? Listen. Again, girls, in mechanics, we're not concerned about what physics. We're concerned about what mathematical model and what and solving physical problems. Simply, we're concerned about the definition of momentum. Momentum is the product of what? Mass times what? Velocity, right? Velocity, not speed. P is momentum. Actually, it's small letter. P is momentum. M mass. Right? M is what? Mass. V velocity. Okay? Momentum is a vector. Momentum is a vector quantity. So we have to determine the positive direction before solving the questions about momentum. Secondly, the unit either Newton, kilogram per second or Newton second. مش Newton.
Newton meters, huh?
Kilogram meters per second. Okay, or what? Newton second. Okay, this is the unit for what? For the moment. It's a vector quantity. We need only these details about the basic things, the definition, unit, vector, and also it's a vector. And we're concerned about the momentum during the collisions. And mainly we're concerned about what? Momentum what? During what? The collisions. Let's say we have two particles moving. In order to understand this.
There's what chapter is that?
Chapter 3, section 3.7 to 3.8. This is the last topic in chapter 3. Okay, guys. Now let's say that we have two particles that are moving towards each other. Let's say this is M1. It has mass M1, and this one has mass what? M2. Before the collision, this was moving with the speed U1, and this was moving with speed what? U2. After the collision, one of the scenarios that their speed and direction may change as a result of the collisions, right? As a result of this collision, one of the scenarios that might be happen, the direction and the speed of these these particles may change, right? So M1 may move in this direction, and M2 may move what? In this direction. Okay? So after the collision, the speeds will be what? V. Right? Here it's what? V2. So we will use U for speed before the collision, immediately before, V1 immediately after. Immediately before, immediately what? After. Here, we will use the law of conservation of momentum. Law of conservation of momentum. Linear momentum, right? What does this law say? Yes, total momentum for the system before is equivalent to the total momentum of the system where after. Yes, exactly. Yeah. Total momentum before equals what? Total momentum where after. What does this mean? Look here, please. P1 plus P2 before equals what? P1 plus P2 where? After. This is the law of conservation of momentum, okay? You know, during any collision, the total momentum of the system will be conserved. It will not change, the total, right? What is P1? M1 times what? U1, right? Momentum is what? M times V, right? That will be what? M1 U1 plus M2 U2, which is equal P after, P1 after, which is what? M1 V1 plus what? M2 V2. This is the formula that will be regularly used. M1 U1 plus M2 U2 equals what? M1 V1 plus M2 V2. Here we have to take into consideration also the positive direction. Yani we have to determine what? The positive direction. This is the first important point. The second point, we have to understand that in U1 and U2, listen, U1 and U2 are the velocities immediately before the collision, right? Immediately what? Before the collision. U is the velocity immediately what? Before. While V would be used as for the velocity immediately what? After the collision or after any process. Okay? Right? So this is the formula we used. Any question? Look here, girls. Also, we have to define something called what?
Impulse.
Impulse. Okay, we have to define something called what? Impulse. What is the definition of impulse? Impulse is P final or P after minus P what? Before. Yani momentum, just a moment. The definition for the impulse is what? Momentum after the collision minus what? Momentum what? Before the collision. In other words, M V minus what? M U. This is what? This is what? The impulse. To understand the impulse, look here please. The impulse is occurred during the collision. شوفوا ايش حكي لك. احنا هون we are talking about immediately before or immediately where? After. Now the impulse is occurred during the collision. يعني at the moment where the collision is occurred. This way, here. Let's say this is A, let's say, and this is what? B. What will happen here? B pushes A where? This way. This is called impulse. B on A. Right? Impulse B on A. As well, A will exert also impulse on B in the opposite direction. Equal in magnitude but opposite in direction. This will be what? A on B. The two values IAB or IBA are equivalent, right? But in the opposite direction. Yani IBA equal minus I what? AB.
The sum equals to 0?
As magnitude, yes. As magnitude, IBA equals what? IAB. As value, IBA equal what? IAB. Clear? Any question? Okay. Guys, listen. Listen, please. Listen again. Listen here. Pay attention. Pay attention. Again, girls. During the collision, look here, please. There is an impulse. yeah, there's an impulse what? B on A, or A where? On B. This value of this formula actually for single particle. For single what? Particle. Pay attention, it's an important point. This for what? For the system. This formula for what? For the system. The impulse will be used for single particle only. Will be used for single particle. Actually, we mainly will use this and this. In all the past paper questions, also the book questions. Fine? So, look to exercise 3H. 3H. Page 72. Exercise 3H, page 72. Okay? Mainly I will write here, sorry, M1 U1 plus M2 U2 equals M1 V1 plus M2 what? V2. The other important formula M1 U V1 minus M1 U1. Right? Okay? We will use only these formula, these two, in order to solve the questions. Okay, guys. Look to 3H. Guys, look to 3H, please. A particle P of mass, question 1. 3H, page 72. A particle P of mass 2 kilograms is moving on a smooth horizontal plane with a speed 4 meters per second. It collides with the second particle Q of mass 1 kilogram is at rest. So these given values, right, before what? The collision. A, or P, sorry, has mass 2 kilograms, was moving in this direction with the speed U1 equals what? 4 meters per second. As a result of this motion, it will collide with the Q at rest, so U2 equals what? 0, which has mass 1 kilogram. So this is what? M2. After the collision, P has a speed 2 meters per second. P has a speed 2 meters per second, which is V1. Okay? And look, and it continues to move in the same direction. Continues to move in the same direction. Find the speed of Q after what? The collision. We don't have the information given about what? Q. Okay. So, now, what I have to do?
M1. V1.
Yes, exactly. Look, I have all the information given to find, so this formula can be used. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. Before substituting, please, what I have to do? I have to determine the positive direction. In any direction that you want, this is what? The positive direction. So, this is positive, and this is what? Positive 2. Clear? Any question about this? Substitute now. It's easy. M1 is what? 2. U1 4 plus M2 1 times 0 equals M1 again 2 times positive 2 plus 1 times X or V2. Right? So this becomes 8 4 plus what? V2 minus 4 minus 4. V2 equals what? 4. Positive 4. What does this mean?
Like this.
From the substitution. This means that Q is moving what?
Also
This direction, in the positive direction. if I got negative, listen. If I got negative, so Q is moving where? In the opposite direction. Clear?
Okay.
Any questions?
No. So does that have the direction?
Yes. Determine the direction. Look to question 5. In question 5, two particles A and B of mass 2 kilograms, A, B, M1 2 kilograms, M2 what? 5 kilograms. Please stop. Please stop. Okay. Are moving towards each other. Are moving what? Towards each other. On a straight line on a smooth horizontal surface. The particles collide. Before collisions, speed of A, U1, 6 meters per second, right? And B, which is 2, U2, 4 meters per second. Okay? This is before the collision. After the collision, the direction of the motion of A is reversed. This is before. This is what? After. It's reversed. And the speed becomes what? 1.5 meters per second. This is after. We are asked about what? The speed and direction of B after what? The collision. Then the magnitude of what? Of impulse. Magnitude of?
أكيد B راح كمان inverse.
You cannot judge. We have to calculate. I think, by the way, A may push B in this direction or the opposite way. Okay, no matter. And I can't judge now. I have to make the calculation. Before doing the substitution here, I have to determine what? The positive direction. This is the positive direction. So this is positive. This is what? Negative. Pay attention here. This is positive. This is what? Negative. And U2 is what? Negative 4 meters per second. U1 is what? Positive 6 meters per second. Okay? V1 is what? Negative 1.5. V1 is what? Negative. Why? Because now after the collision it's moving where? In the opposite what? Direction. My positive direction. Okay? We will use the same formula. M1 U1 plus M2 U2 equals M1 V1 plus M2 U2. M1 U1 plus M2 U2 equals M1 V1 plus M2 what? V2. Let's substitute now 2 times U1 positive 6 plus M2 is what? 5
Negative 4.
times what? Negative 4. Be careful. The main point here we have to take into consideration, or we have to be very aware about what? The signs. Okay? Positive and negative. Equals. M1 is what? 2. V1 is negative 1.5. Plus M2 5 times V2. Clear, guys? Okay, now 2 times 6, 12. 12 minus 20.
Minus 8.
Minus 8.
Minus 3.
Minus 3. Plus 5. V2.
Minus 5.
Plus 3. Plus 3.
Minus 5 equals 5 V2.
Minus 5 equals 5
V2.
V2.
Over 5
So
over 5.
V2 equals what? Minus 1 meter per second. Now my question. Listen. Negative means where?
The opposite direction.
Not its opposite direction. Here. This one. This direction.
Yeah.
Look. B.
So same direction.
Yeah, excellent.
So
Does B,
لا.
okay, reverse its direction? No. Okay? The direction of B is not reversed. Because, listen to my words. Listen, please. Pay attention. Before it was negative, or after it's what?
Negative.
Negative. So it's it will continue in the same direction. It will continue in the same way.
بس ممكن كمان انه في شيء ثاني انه لانه A الماس تاعها اقل من B فمستحيل A تبوش B.
Let's say.
Depends on speed. Oh, more.
Okay, guys. Look, it's not the whole story because here we did not consider only the mass, the momentum. يعني هو المومنتم what before 2 plus 6, 12, right? Here 5 times 4, 20, which has the higher momentum B. So B, so A as a result of that, when B collides with A will change the direction. Okay, A will change what direction? Clear? Now, what we are asking B
The magnitude of the impulse.
of the impulse, right?
Given by A to B.
Yes, given by A to B. Okay, given by A to B. What does this mean? Look here, please. Given by A to B.
A on B.
Yani impulse A on B. This will equal M B V B minus M B also U B. Be careful about this. An impulse is taken for the same particle, right? Or for single particle. Pay attention here. The impulse is taken for what? For the same particle. Clear? So what I have to do? For B. Look, for what? For B. Mass for B is what? 5. Final velocity of B is what? Minus 1. Equals 5 minus, sorry. 5 times minus 4. Hey, look, before, after, V is what? After. I will after for B. Minus 1, right? Minus 1. U before for B minus 4.
15.
This becomes what? Minus 5 minus 20, right?
15.
Which is what? 15. Newton what? Second. Newton second. The unit for impulse would be the same as the unit for momentum. For momentum. My question now, if I calculate the impulse for A, what is the result?
Same. It's opposite.
Same but negative. And if I calculate, look, if I calculate B on A, same impulse, but in the opposite what? Direction. Clear?
Can I ask you a question?
Yes.
Hello, like when we have to, let's say, A will be there, like after they collide, A will have the same impulse as B because of the collision, or before they both have the same?
Actually, this is because of Newton's third law. Newton's third law, listen girls, why the impulses are equal? Listen, pay attention. Why the impulses are equal? Because every action has equal and opposite what? Reaction. Clear?
No, but like in momentum for A, and after the collision, it became equal.
Momentum, be careful, momentum are not equal before and after.
Yeah, oh, okay.
You got the point?
Yeah.
Total momentum before equals total momentum what?
After.
After.
Okay.
But the individual momentum before and after are not equal.
Okay.
Okay?
Okay.
Fine? Fine. If you have finished 150 grams, question 8 guys. An explosive charge of mass 150 grams is designed to split in 2 parts. Here we don't have collision. Here we have one particle splits to what? 2 particles. Okay? Same thing, I will use the law of conservation of momentum. It's designed to split to 2 parts with mass 100 grams and the other with mass what? 50 grams. So before, we have only one particle with a mass 150 what? Grams. When the charge is moving at 4 meters per second, it was moving at U equals 4 meters per second. Okay? This is what before the split. It splits after, what will happen after? It splits the two parts, right? The larger part continue in the same direction. It's mentioned in the question, right? This larger part has 100 grams mass. Let's say this is M2. The small one is what?
In the opposite.
50 grams. Why is the smaller part moves in the opposite direction? This way. It's given that the speed of the larger part is twice the speed of what?
يعني U to U.
Yes, hereafter.
So shouldn't we convert G into VG?
Yes, definitely. Okay, here V2, here what?
V1.
V1. Why V2 is double what?
U.
V1. Right? It's given like this. The speed of the larger particle, what? It is twice the speed of what?
The smaller
The
one.
smaller one. What we are asked to find? The speed of particle, larger particle, smaller particle. Okay, fine. So we'll use what the law of conservation of momentum. Basically, we can convert the masses to kilograms, and this becomes what? 0.50 kilograms. This becomes 0. kilogram, 100, and this becomes what? 0.50 kilogram. If we did not convert them, also the same thing. Okay, which equation should I use? This one. Okay? But we don't have what? M2, what? U2. Here, M times what? U equals what? M1 V1 plus M2 what? V2. This is the law of conservation of momentum. The total momentum before equals the total momentum where? After. M1. We did not determine what? The positive direction is. This is what? The positive direction. Please show this for the examiner, okay? M is what? 0.15. M is what? 0.15. Before times U 4 equals M1, this one, 0.05 or 50 times V1 negative V1. Why negative? With opposite direction. This is minus V1. This is what? Plus 2V1. Clear? Any question about this? So, plus M2 0.100 times what? Positive 2V1. Now we have only one variable, which is what? V1. This becomes, I think this is 0.6, right?
0.6
Equals minus 0.05 V1 plus 0.200 V1. Any question about substitution here, 2V1?
No.
Sure? Now this becomes what? 0.15 or V1 equals what?
0.15 V1.
So V1 equals what? 4 meters per second. V2 8 meters per second, because V1 V2 is double what? V1. Clear? Yes.
But this one at M equals 0.15 or 0.05.
This one?
You switched it from grams to
I converted the grams to kilograms.
So المفروض يطلع V1 negative.
I substituted already negative form
Okay.
because it's given to us. Guys, here that's right. But it's mentioned the question, you know, it's in the opposite direction. So I already substituted minus here. Okay, fine. Right. Look now to question 9. Ten, sorry. Look to question 10, please. In question 10, two particles A and B of mass 4 kilograms and 2 kilograms. Pay attention. I will give you time to complete copies. Respectively are connected by light inextensible string A and what? B. They are connected by what? Light and extensible what? String. A 4 kilograms. B what? 2 kilograms. Let's say this is M1.
طب ليه عامل سلاك بالسترينج؟
M2. هلا تشوف ليش.
عشان كوليجنز يعمل مطاط.
The particles are at rest on a smooth horizontal plane with a string slack. With a string slack. Particle A is projected directly away, okay, with a speed u. Okay? A is projected away from B with speed what? U. It's projected away directly, okay. When the string goes taut, and after the collision, this is what? After the collision, the impulse transmitted through the string has a magnitude of what? 6 Newton second. Okay, 6 Newton second. What we are asked? Common speed and the value of u. Pay attention, Billah, please. Hello, this is before. This is what? Before. After, what will happen? The string goes taut.
A will change direction.
Right? So, here it's given that there is an impulse transmitted, okay, a 6 Newton second, right? Impulse transmitted. Where is the direction of impulse transmitted? A on B? A on B.
On هيك. هيك. لا بالعكس.
هيك. بالعكس عكس.
A on B. Pay attention. Here, A, yes, A pulling B in this direction.
So this way. The impulse is this way.
No?
Why?
It's pulling it that way.
Actually,
It's pulling it
Yes.
this way. Impulse is the opposite direction.
let me explain this. Girls, look. Look, please. Hello, when two particles collide, again, listen. Look here, please. When two particles collide with each other, look here, please. They collide. A exerts force on B where?
Like
In this direction. As well, B exerts force on A where? This direction. Yes, here, look here, please. A exerts force on B where? In this direction. As well, B will exert force on A where? In this direction. So that here the impulse will be this direction. This is the impulse of what? B on A. صح? B will pull A in this direction. While A, right, pulls B where? This direction. This is what? A on B. Why we have to determine this? Because we have to determine the sign, positive or negative for the impulse too. Okay, let's now answer the question. And after the string goes taut, they have common speed. They will have what? Common speed. And they will move as a one particle. They will move as what? One particle. Okay, so look here, please. Can I use M1 U1 plus M2 U2 equals M1 V1 plus M2 U2? I don't have the information given. Right? But M1, let's say M1 U1 unknown, صح? M2
They gave us I.
unknown, right? Yes, I will use what? The formula of impulse because we are given the impulse. We are given what? The impulse.
هي A B صح؟ B.
طبعا هاي V, sorry. After high speed becomes V, right? After the collision, after the string goes taut, the velocity becomes what? V. We don't have information given for the first formula, but I can find it for what? For the second. Pay attention, where is the positive direction?
Yeah.
This way. Which particle I will use the impulse for A on B? Why? I will show you why. MB VB minus MB UB. Why did they use an impulse on B? Pay attention. I used the impulse on B because the initial speed before is what? Is known. It was at rest. It was what? At rest. فهمتوا ليش؟ يعني I used B or I used the impulse on B because the initial speed for B before is what? 0. يعني U here it was what? 0. Okay? It's mentioned that the question would be where B was at rest. B was at rest. No matter. Take this as a positive direction. Is there any problem? Is there any problem?
And why did you do B on A?
أنا أخذت A on B. بحطها negative, yes. Guys, yes. هذا before طلع من شو طلع question. Particles A and B mass 4 and 2 respectively. The particles are at rest on a smooth horizontal plane with the string slack. Then, اسمعي بالله. Listen. Particle A is projected directly away. هلا still the string is slack, but A is moving where? In this direction. When the impulse is transmitted, when the string goes what? Towards. صح؟ فهاي before وهاي after. ما قلنا B comes to rest. نقول B where was at rest. Okay. بعدين A is projected away. هذا اللي before, right? Okay. Otherwise, no impulse will be transmitted through the string. If A and B at rest, there is no impulse will be transmitted through the string. Look here, please. طلع معي هون. قديش الامبلس تبع AB؟ -6. الامبلس of BA 6. Guys, انتبهوا معي هون. Again, الامبلس AB -6, right? Impulse B on A 6, same thing, بس ايش؟ opposite direction. So how it becomes what? -6 equals mass of B 2 V minus what? 0. So V equals what? -3 meter per second. Actually, this is the common speed for A and B. This one is the common speed for A and B because if you remember, when the string goes stopped, right? Both particles have the same acceleration, tension, initial, final, displacement, same thing, right? Clear? So this is what the common speed, right? After what? After the string goes taut. What we are asked to find later. This is a U. I can use any of the equations, right? I can use any of the equations. But I will use what? BA equals, pay attention, Sham, MA VA minus MA UA. B on A. B on A. MA VA minus MA UA. على فكرة بسأل لحدا pay attention يعني عادي.
No قصدك شام.
ما يعني ما حكيت اسمي. قديش BA 6 equals mass A 4
-3
V minus 3 لأنه قلنا هاي common speed for A مين و B minus 4 برضه بمين؟
-V
بيو
-U
أستاذ يو بتطلع فوق
negative U yes
minus
بتصير
4.5
بلس
same thing قديش بيطلع U؟
minus 4.5
minus 4.5
meter per second.
clear؟
لا